of the basic operations of OSPF. This will be just a quick introduction. In the next video, we'll go really in-depth. Then I'll talk about OSPF areas, which is a unique feature of OSPF that splits larger networks into smaller sections. Finally, I'll show you some basic OSPF configurations, like I showed you before for RIP and EIGRP. Watch until the end of the video's quiz for a bonus question from Boson XSIM for CCNA. XSIM is a set of practice exams for the CCNA. I used them myself when studying for my CCNA, and also I used XSIM for CCNP too, and I really think XSIM is an essential study tool. If you want to get XSIM, follow the link in the video description. Okay, let's get started with OSPF. First up, here's the same chart of the different kinds of routing protocols I showed you before. Remember that OSPF is a link state dynamic routing protocol. You'll see in this video that it functions quite differently than the distance vector routing protocols RIP and EIGRP. To review, distance vector protocols use routing by rumor, in which each router shares information about the routes they know and their metric cost to reach each destination. However, the routers don't have a complete map of the network. They just use the information their neighboring routers tell them to determine the best route to each destination. Now let's review how link state protocols function. Here's another slide I showed you in day 24's video. When using a link state routing protocol, every router creates a connectivity map of the network. To allow this, each router advertises information about its interfaces, its connected networks, to its neighbors. These advertisements are passed along to other routers until all routers in the network develop the same map of the network. This is important. All routers have the same complete map of the network. Then, each router independently uses this map to calculate the best routes to each destination. Due to this process, link state protocols use more resources on the router because more information is shared. It's more demanding on the router. However, link state protocols tend to be faster in reacting to changes in the network than distance vector protocols. So that's a quick review of link state routing protocols. Now we'll start to go in depth about how OSPF functions, and you'll get a deeper understanding of what all this means, and see how different it is to RIP and EIGRP, but also you'll see the similarities. So let's get started with OSPF. OSPF stands for Open Shortest Path First. The OSPF protocol uses the shortest path first algorithm, created by Dutch computer scientist Edsger Dijkstra. Another name for the algorithm is Dijkstra's algorithm. Remember that name. It could be an exam question. There are 3 versions of OSPF. Version 1 was released in 1989. It's old and not in use anymore. Version 2 was released in 1998, and this is typically the version that is used in IP version 4 networks. Take a look at the exam topics again. The version of OSPF in the exam topics list is version 2. So when I talk about OSPF in these videos, I will be talking about version 2. There's also OSPF version 3, which was developed for IPv6. It can also be used for IPv4, but version 2 is more common in IPv4 networks. Okay, now a couple general points about OSPF. Routers store information about the network in LSAs, link state advertisements, which are organized in a structure called the LSDB, Link State Database. LSA and LSDB are 2 important terms for OSPF. I'll talk more about them throughout these videos on OSPF. Routers will flood LSAs until all routers in the OSPF area develop the same map of the network, meaning the same LSDB. So those are 2 more important terms, flood and area. We already know the term flood. Switches do it when they receive a broadcast or unknown unicast frame. In the case of OSPF, it means they send the LSAs to all of their OSPF neighbors. OSPF areas are a unique aspect of OSPF, and I'll talk more about them later in this video. Let me briefly elaborate on the last 2 points in the previous slide, about LSAs and the LSDB. So let's say this network of 4 routers is running OSPF. All of these routers are OSPF neighbors. They have the same link state database, and the network is stable. Then, OSPF is enabled on R4's G10 interface. So R4 needs to tell the other routers about this new network segment. So R4 creates an LSA to tell its neighbors about the network on G10. An OSPF LSA contains more information than this, and we'll look deeper later, but some of the basic information in an LSA is the RID, the router ID. For this demonstration, R4's router ID is 4.4.4.4. None of its physical interfaces have an IP address of 4.4.4.4, so either R4 has a loopback interface with the IP address 4.4.4.4, or the router ID was manually configured. The network on the G10 interface is, of course, included in the LSA, since that's the main purpose of the LSA. R4's cost is also included. I'll talk more about OSPF's metric, called cost, in the next lecture, but this gigabit Ethernet interface has a cost of 1. The LSA is then flooded throughout the network until all routers receive a copy. That looks like this. This results in all routers in the OSPF area having the same LSDB. The LSDB is like this, containing LSAs for all of the different links in the network. Now that OSPF has been activated on R4's G10 interface, that new LSA is added to the LSDB. I'm going to repeat this many times, I'm sure, but remember that this LSDB is identical for all routers in the OSPF area. Each router then uses the SPF algorithm, Dijkstra's algorithm, to calculate its best route to 192.168.4.0/24. Remember, each of these routers has a complete map of the network. So, for example, you and I, looking at this diagram, can see that R2's best route to 192.168.4.0/24 is this route via G10. Well, R2 is basically looking at the same diagram, so it can calculate that sending traffic via G10 is the best route. It's not looking at a visual diagram like we are, of course, but in effect, it's the same thing. Finally, note that each individual LSA has an aging timer, which is 30 minutes by default. The LSA will be flooded again after the timer expires, so once every 30 minutes by default. Let me summarize the process. In OSPF, there are 3 main steps in the process of sharing LSAs and determining the best route to each destination in the network. Step 1 is to become neighbors with other routers connected to the same segment. In the network in the previous slide, for example, R4 was OSPF neighbors with R2 and R3. Step 2 is to exchange LSAs with neighbor routers, which you saw in the last slide. Then each router independently calculates its best routes to each destination and inserts them into the routing table. I will cover these steps in depth in the next lecture. Just keep in mind this basic process of OSPF. Let's move on to another fundamental concept of OSPF, which isn't part of RIP or EIGRP, OSPF areas. OSPF uses areas to divide up the network. However, small networks can be single area without any negative effects on network performance. For example, this network with 4 routers is a small network. When configuring OSPF in a network like this, we can use just a single OSPF area, and there won't be any degradation of network performance. In larger networks, however, a single area design can have some negative effects. For example, if the OSPF network had 500 routers with over 1,000 subnets instead of 4 routers and just a few subnets, using just a single OSPF area would be a bad idea. You should divide a large network like that into several smaller areas. Now, what are some of the negative effects of using a single area design in a large network? Well, for example, the SPF algorithm takes more time to calculate routes in a large network. It also requires exponentially more processing power on each router to make calculations. Each router sharing a single huge link state database also takes up more memory on the routers. On top of that, every small change on the network, for example a new interface being activated, would cause LSAs to be flooded to all 500 routers, and all of those routers would have to do the SPF calculation again. By dividing a large OSPF network into several smaller areas, you can avoid the above negative effects. Checking the exam topics once more, notice that only single area OSPF is mentioned. So I will only give a brief overview of OSPF areas and how they work. You don't need too much detail for the CCNA. I'm not going to make a diagram with 500 routers, but here's an example of a larger network than the previous one. It's possible to make this one large single area network. All interfaces on all routers are assigned to area 0, also known as the backbone area. You'll see soon that Area 0 is of special importance in OSPF, and it's called the backbone area. Now, instead of one large area, I'll show you how the network can be divided into separate areas. Here's how it's done. Now, there are some rules and terminology you should know about OSPF areas. I'll explain them now. First up, what is an area? It's a set of routers and links that share the same LSDB, link state database. Looking at this diagram once more, how many areas are there? Area 0, Area 1, Area 2, and Area 3. So there are 4 areas. Each of these areas maintains a unique LSDB. Next, the backbone area, which is Area 0, is an area, a special area, that all other areas must connect to. Let's check that network diagram again. Notice that Area 1, Area 2, and Area 3 all connect to Area 0, the backbone area. This kind of network design, for example, is not allowed in OSPF. Notice that Area 1 is not connected to Area 0, the backbone area. It is only connected to Area 2. This is not allowed in OSPF. Next up, routers with all interfaces in the same area are called internal routers. So in this diagram, which routers are internal routers? If all of the router's interfaces are in the same area, it's an internal router. This router here is internal to Area 0. These routers are internal routers in Area 1. Same for these routers in Area 2, and these routers in Area 3. So those are internal routers. Routers with all of their interfaces in the same OSPF area.
Oh my god.
Next up, routers with interfaces in multiple areas are called area border routers, because they are the border between different OSPF areas.
I'm just here.
In this network, which routers are ABRs? This router connected
Interrupting
to Area
the
0 and
discussion.
Area 1 is an ABR.
APR.
This router connected to Area 0 and Area 2 is also an ABR.
That's an.
And this router connected to Area 0 and Area 3 is an ABR.
Do you know what an APR
So
is?
remember that ABRs, area border routers, are routers with interfaces in multiple OSPF areas. One more bit of information about ABRs. ABRs maintain a separate LSDB for each area they are connected to. It is recommended that you connect an ABR to a maximum of 2 areas. Connecting an ABR to 3+ areas can overburden the router.
Yeah.
So a design like I show here is good OSPF network design, with each ABR only connected to 2 areas. Next, routers connected to the backbone area, which as I said before is Area 0, are called backbone routers. This includes area border routers, by the way. So which routers in this network are backbone routers? Of course, this router is connected only to Area 0, so it is a backbone router. It is a backbone router and an internal router, internal to Area 0. This router is also a backbone router, on top of being an ABR. Same for this router, and this router. They are both backbone routers and area border routers, ABRs. Next term, an intra-area route is a route to a destination inside the same OSPF area. For example, from a router in Area 1 to a destination that is also in Area 1. Let's see an example. For example, this router learns a route to this subnet. It is considered an intra-area route because the destination is in the same area as the router. Here's the final term. An inter-area route is a route to a destination in a different OSPF area. For example, if a router in Area 1 learns a route to a destination in Area 2, that is an inter-area route. Let's see one more example. If this router in Area 1 learns a route to this subnet in Area 2, it is considered an inter-area route. The router and the destination are in 2 different OSPF areas. So those are some important OSPF terms regarding OSPF areas. Make sure you learn and understand these, and use the flashcards to remember them.
The flashcards.
Backbone area, internal router, area border router, backbone router, intra-area route, and inter-area route. Remember those terms. Next up, let's cover a few additional rules about OSPF areas. First up, OSPF areas should be contiguous. What does that mean? It means that each individual area should be connected, not divided up.
What's contiguous?
It's easier to demonstrate with the network diagram.
Okay.
So, this network satisfies that rule. All areas are contiguous. Now let's look at what it means to be non-contiguous. Area 1 is now non-contiguous. Instead of all being connected, half of Area 1 is here,
Oh,
and half of Area 1 is here.
should only
This
be
kind of
one
network
router.
design is not allowed in
Should only be
OSPF
one
and
router.
will cause problems. So instead of having Area 1 split up and non-contiguous like this, you should make this section on the right a separate area, Area 3. Now all of the areas are contiguous, and OSPF can function properly. Next rule. All OSPF areas must have at least one ABR connected to the backbone area. I actually already mentioned this,
Lucky for
but it's
you,
worth
Ven.
repeating.
We're
Let's look at
not
the
even
network
half.
diagram here. So notice that Area 1 has an ABR connected to both Area 1 and Area 0. Area 2 has an ABR
We're
connected
not
to
even
both
halfway.
Area 2 and Area 0.
Yes.
And Area 3 also has an ABR connected to both Area 3 and Area 0. This is correct OSPF network design. As I showed you
Right.
before, a network like this is not correct OSPF network design and will cause problems because Area 1 does not have an ABR connected to the backbone area, Area 0.
Yes, all ABRs
One
must
more
connect to the
OSPF
backbone.
interfaces in the same subnet must be in
Yeah.
the same area. If they're not in the same
Yeah.
area, they won't become OSPF neighbors and won't exchange information about the networks they know about. In a future video,
We
I
should
will
take
go
a break
more in
after this
detail about
section.
some other requirements for
I need
routers
like-
to become OSPF neighbors. But for now, let's leave it at this one.
Yeah.
So let me demonstrate.
Mhm.
In this example, these three routers all have an interface in Area 0
Yeah,
in the
yeah, yeah, yeah.
192.168.1.0/29 subnet.
Mm.
This router also has an interface in the 192.168.1.0/29 subnet, but the
Mm.
interface is in Area 1, not Area 0. Even though all four
Right.
interfaces are in the same subnet and OSPF is enabled on them, the Area 1 router will not become OSPF neighbors with the others.
Right.
This time, the Area 1 ABR's interface in the 192.168.1.0/29 subnet is correctly configured in Area 0. So, all four routers will become OSPF neighbors.
Yeah.
Here's a summary of those three rules.
We got a summary.
Of course, I will cover many more points about OSPF in the next few videos. I will go in depth about OSPF neighbors, OSPF LSAs, and other points. But now let's cover some basic OSPF configurations, so we can practice them in the lab video.
Wait, we're going through that
So
now. Wait! I need a break from that. That's why I chose I'm a developer. What? I didn't want to be a developer because I hated coding. I realized it a little too late. Coding is not for me. And I really enjoyed doing all this. So right now, I'm studying network security and all that fancy stuff. Yeah. So I'm working on it. Just gotta, you know. I'm the server guy. The man who serves. I don't even know if that makes sense. Everyone okay? Are y'all okay? You know, originally my productivity stream wasn't supposed to be this. It was supposed to be me editing the video for Eternal Return, the Eternal Return guide video. Yeah. But I realized I have a test for this tomorrow. And whoopsie. All I can say. I'm not too worried about the test though. Because one of the main reasons why I'm doing this again is because my instructors say that this is one of the longest and most difficult, and after that it should be a breeze. And I'm also taking the official examination for this whole Cisco certification. So I have to. I'll probably come back to this video by summer. In this channel, Jeremy's IT lab, he's one of the best. Like, so many people praise him for explaining things so much easier. And yeah, I can't deny that. Like, he is actually so good at explaining. But I just really have to endure boring concepts. But I learned a lot of things. When we actually need to be productive in a productivity stream, no way. No way. Okay, need to have that in a. Well, I wanna tweet that. No way. No. I have not heard of. Has it been 5 minutes yet? How long is part 2? Another 36 minutes? No, I'm not doing all that. I am not doing all that today. Might go through it in the morning. Holy moly. Not only that, like, there's a part 3. There's 3 parts. And they're all 36 to 47 minutes long. It's so over. Yo, I'm thugging it out. Let's move forward, guys. After this video, I don't know what to do.
Practice them in the lab video. So let's use the same network topology that we did for RIP and EIGRP.
RIP is obsolete, no one uses that.
Although
EIGRP is Cisco
proprietary.
proprietary.
And terms about OSPF areas, for the CCNA, you only have to configure single area OSPF.
Right.
So all of these router interfaces are in OSPF area 0. I've already configured R2, R3, and R4. So let's configure OSPF on R1. Here is the basic OSPF configuration. Let's walk through it.
Okay.
First up, to enter OSPF configuration mode, you use the command router OSPF followed by a process ID.
Okay.
A router can run multiple OSPF processes at once, and this ID is used in the router to identify each of them. Typically, you'll just use a single OSPF process, so don't worry about this number. I chose to
Okay, we don't care about the router
the
number.
EIGRP configuration. You use the command router EIGRP followed by an AS number. For EIGRP routers to become neighbors, their AS number has to match. However, the OSPF process ID is different. the OSPF process ID is locally significant. Routers with different process IDs can become OSPF neighbors.
So what's it
Usually,
for?
I just use process ID 1, but you could, for example, use process ID 1 on R1 and process ID 2 on R2, and they would still become OSPF neighbors and exchange LSAs.
So what makes it locally
Note that this
significant?
process ID is totally unrelated to the area. You'll see next that the area is configured separately. So next I attempted
What's it
to
for
use the
then?
network command just like I did in EIGRP. Note that OSPF uses wildcard masks, just like in EIGRP. If you need to review
Wildcard
them, go back
masks.
and watch Day 25's video. Basically, it's an inverse subnet mask.
Yeah.
Anyway, I tried to use that command, but then the router says incomplete command. That's because the OSPF network command requires you to specify the area. So I activated OSPF on all of these interfaces in area 0. Once again, for the
You start at
CCNA,
area
you only
0?
need to configure single area OSPF, and usually you'll use area 0. For single area OSPF, it's actually possible to use any area number, but it's considered best practice to use area 0. Before moving on,
Is
let
it
me
a
review the
security
function of the
breach
network
though?
command. It's just like in RIP and EIGRP.
Or does...
The network command tells OSPF to look for any interfaces with an IP address contained in the range specified in the network command, and then activate OSPF on the interface in the specified area. For example, in the first network command I specified 10.0.12.0 with a /28 wildcard mask in area 0. R1's G00 interface has an IP address of 10.0.12.1, which is contained in 10.0.12.0/28. So, OSPF will be activated on G00 in area 0. When OSPF is activated on the interface, the router will then try to become OSPF neighbors with other OSPF activated neighbor routers. In this case, R1 will become OSPF neighbors with R2 and R3.
Right.
I'll explain that process in depth in the next video. So just
And,
remember that the network command is simply...
So it's using what? I got a message. Huh. Never mind. I would have to check. I was supposed to explain something, but hold on, I have to answer this. Right. Where were we? Right. So this line for R1, which is over here. Oh, I hope my pointer is like visible when I like point at things. So this is R1. And what this command is doing is it connects it sort of like connects the whole network over here. You see it's 10.0.12.0, which is this network, which is the connection of R1 to R2. Um, it just basically activates OSPF. So they just make this link. It just links, basically. You're just telling the router to link to the other routers with this protocol. They're already connected in a sense that they can ping each other. But what we're doing here is just making them follow a protocol. So 10.0.12 R2, 10.0.13, it's this dialog, this box is blocking the way, but it's connected to R3, I think. And then the last one here, 172.16.10, is the local network of router 1. So think of it like, wait, what's an easy way to do this, to explain this? R1 is the router that you have at home, and this 172 network is where all of your devices are connected. This is your local network. And then R2 is more like, the connection of R1 to R2 is like connecting to a different house's router. And they have their own network too, with their own devices. That's not a real example, but it's the easiest way to explain it. Okay, moving on. Yeah.
Used to tell the router which interfaces to activate OSPF on. It doesn't tell the router, advertise these networks. But we already covered that in the last video. Now let's look at a few other configurations you can do in OSPF. First up, the passive interface command.
What?
You already know this command from RIP and EIGRP. It's totally the same for OSPF. The passive interface command tells the router to stop sending OSPF hello messages out of the interface.
We will use this
OSPF
on
uses
this
hello
interface then.
to tell other routers about itself. Wait for day 27's video for more details on that. However, the router will continue to send LSAs informing its neighbors about the subnet configured on the interface.
Right, we use it here.
Although R1 won't send hellos out of G20 and try to find OSPF
Use
neighbors, it will still tell its other neighbors about the 172.16.1.0/28 network. You should always use this command on interfaces which don't have any OSPF neighbors.
Right,
It's
because
a way to
OSPF
continuously send
is
hello
just all about the
messages
routers.
out of an interface with no other routers connected to it.
Right.
So that's the passive interface command. It's basically the same as for RIP and EIGRP. Next up, let's see how to advertise a default route into OSPF, just like I showed you before for RIP. So I've added an internet connection to R1. Then I configured a default route on R1, and the next hop is the ISP's IP address of 203.0.113.2. Here is that information in the routing table of R1. Feel free to pause here if you want to check out the other OSPF routes that R1 has learned too. Just like I showed you in RIP, the command to advertise the default route into OSPF is default information originate. In OSPF, this will cause the router to create a new LSA and flood it. I checked R2's routing table, and you can see it added the default route via R1 to its route table. R3 and R4 would also do the same.
Right.
Now let's take a look at the show IP protocols command from an OSPF perspective, and we'll check out some other commands as well. Up top it says routing protocol is OSPF 1. 1 is the process ID.
That's the process ID. Yeah.
OSPF also uses a router ID, and the router ID is determined in exactly the same way as an EIGRP. Let's review it. Here is the order of priority when determining the OSPF router ID. First up, if you manually configure the router ID, that will become the router ID. If you don't manually configure the router ID, the highest IP address on a loopback interface will become the router ID. If the router has no loopback interfaces with an IP address, the highest IP address on a physical interface will become the router ID. Currently, R1's router ID is 172.16.1.14 because I haven't manually configured the router ID,
right?
and I also haven't configured a loopback interface.
No, that's the
on
physical
R1.
interface earlier.
Let's see how to manually configure the router ID. From OSPF configuration mode, use the router ID command. This is a little different from EIGRP. In EIGRP, the command is EIGRP router ID, but in OSPF, it's just router ID. So I entered a router ID of 1.1.1.1, but then the router displayed this message. Reload or use clear IP OSPF process command for this to take effect. So currently, the router ID is still 172.16.1.14. To make 1.1.1.1 take effect, we have to either reload the router or use that command to clear the OSPF process and reset it. I did that. From privileged exec mode, I used the command clear IP OSPF process.
Would you actually do that in a real life setting?
This basically resets OSPF on the router. This is a bad idea in a real network.
Okay.
And the router will lose all of its OSPF routes for a short time and won't be able to forward traffic to those destinations.
Right, you're shutting down a network for a bit just for this.
It's not a problem. As a side note, notice the no in square brackets. When you see this after entering a command, it means no is the default choice. If you just press enter, the router will assume no and not clear the OSPF process. However, I typed yes, so it was cleared. Then I did show IP protocols again, and you can see that the router ID is now 1.1.1.1. Now let's look at the rest of the command. Take a look here. It is an autonomous system boundary router. An autonomous system boundary router, or ASBR, is an OSPF router that connects the OSPF network to an external network. R1 is connected to the internet. By using the default information originate command, R1 becomes an ASBR. It connects the OSPF network to the internet. So that's why we see this output here on R1. Next up, number of areas in this router is 1. 1 normal, 0 stub, 0 NSSA. These are 3 different types of OSPF areas. It's not necessary to know about the different types for the CCNA. Just wanted to point out that you can see the number of areas this router is in. Just one, because this is single area OSPF. Next, maximum paths is 4. Unlike EIGRP, OSPF doesn't support unequal cost load balancing, but it does support ECMP load balancing over a maximum of 4 paths by default. To change the maximum number of paths, use the maximum paths command, just like in RIP and EIGRP.
Okay.
Here I changed the number to 8. The routing for network section shows the network commands we used. To repeat myself, this only determines which interfaces OSPF will be activated on. It doesn't tell OSPF to flood LSAs for these specific networks.
Yeah, because that's what
Here's the
default information originate does.
And here are R1's neighbors. Notice the router IDs. I configured these loopback interfaces on R2, R3, and R4, and their IP addresses became the router IDs. Finally, down here OSPF's AD is displayed. The default is 110, as you know.
AD is administrative
the
distance.
is the same as for RIP and EIGRP. From OSPF configuration mode, just use the command distance. For example, I changed it to 85, so OSPF routes are preferred over EIGRP routes on this router. That's all for the lecture. We covered a lot of information, but lots of it is similar to or the same as what we learned about RIP and EIGRP.
Oh, hold on. Let's go back there a bit. Right, AD is administrative distance. And you usually use this command for the default information originate command for routers that are directly connected to the internet, which means it becomes the ASBR, or it's like it's basically a big boy router. So everything else that's connected to it, which is R2 to R4, are not that significant. So you don't need to use this. Very cool. Wait, that's the end of the lecture. You know what? Let's do the quizzes.
Here's quiz question 1. Which of the following statements about OSPF are not true? Select 2. A. In multi-area OSPF networks, all non-backbone areas must have an ABR connected to area 0. B.
No.
Single area OSPF must use area 0. C.
No.
Two OSPF routers with different process IDs can become OSPF neighbors.
Yes.
D. The OSPF area must be specified in the network command.
Yes.
E.
A.
An ASBR connects the internal OSPF network to networks outside of the OSPF domain.
My English machine broke.
And F.
Wait, there's
The
an
OSPF
F?
process ID must match the area number.
Oh, hell no. Well, wait, I don't remember anything about multi-area OSPF. All non-backbone areas must have an ABR connect. Oh wait, no. Yes, this is true. This one's true. Because if you don't have an ABR, OSPF will not work. So this is true. Single area OSPF must use area 0. No, you can use any other area, but it's common practice. C is true. Doesn't matter what process IDs you use. D is yes, you have to. E, an ASBR connects the internal OSPF network to networks outside of the OSPF domain. Is this the one with the default originate command? This must be true. This has to be true. Because this one's the one connected to the ISP. And then F, OSPF process ID must match the area number. No, it doesn't even matter. Only the area number matters for other routers. So it's F and B, right?
Pause the video to think about the answers. Select
Oh,
2.
I just did that, Jeremy.
The
B and
answers
F.
are B and F. Although it is common practice to use area 0 for single area OSPF, you can actually use any area. And the OSPF process ID does not have to match the area number. In fact, in multi-area OSPF,
Oh my god.
there will be multiple areas operating in a single process.
Smart.
So it's impossible to match the process ID to all area IDs. The other statements are all true. Let's go to question 2. You want to activate OSPF on R1's G01 and G02 interfaces with a single command. G01's IP address is 10.0.12.1/28, and G02's IP address is 10.0.13.1/26. Which of the following commands should you use on R1?
With a single
Here are the
command?
commands.
What do you mean?
A, B, C, and D. Pause the video now to look at the
Want to activate OSPF on R1's G01 and G02 interfaces with a single command. You're unactivated. Wait, did he ever? Well, one thing's for sure, C and D are not it. Because that wildcard mask doesn't make sense. Why is it .1 and .3? This one is /22. This is /22. This is /23. Well, these don't make sense either. I'm confused right now. Am I overanalyzing it? This is /24. This is not even real. Is it A? But R1 is 0.13. But if we're talking about their IP addresses, then it has to be D actually. That is the only way we can cover both IP addresses, because... Wait. No. It's C or D. I just said they were wrong at first, but now it could be that. C might be the most exact. Because it also has a wildcard mask of 0.0.1.255, which means it covers .13.1. I'm guessing it's a guess at this point. I think it's C.
Commands and find the correct
If I have to use one command, it's C.
The answer is C. Network 10.0.12.0, 0.0.1.255,
Come on, boys.
area
Lock it
0.
in.
This is the only option that contains both IP addresses in its range. So
Lock
it's
it
the only
in.
one that activates OSPF
Lock
on
it
both
in.
interfaces. Let's go to question 3. Answer the following questions about the OSPF network below. 1. How many backbone routers are there? 2. How many ABRs are there? And 3. How many ASBRs are there? Pause the video.
What? Backbone routers. 1, 2, 3, 4. Wait, this one's easy. And then I'll fuck it up really badly. Okay. Backbone routers, there's 4. 1, 2, 3, 4. Okay. ABRs, that's 1, 2, and 3. That's for area 1, 2, and 3, the one that's connected to the backbone. It's 3 routers. ASBRs, there's only one connected directly to the internet, so it's just 1. The answer is 4, 3, and 1, respectively.
Video now to answer each of these questions.
Lock it in, Jeremy. Lock it in. Hey, why am I telling him
Okay,
that?
let's check each of them.
4.
How many backbone routers are there?
4, 4, 4,
There
4,
are
4, 4, 4, 4.
These 4 routers are backbone routers because they all have at least one interface in the backbone
Come
area,
on.
area 0.
Come
How
on.
many ABRs are there?
3.
There are 3.
Lock
These
it
3
in.
routers have interfaces in 2 separate areas, so they are ABRs, area border routers.
Yes.
Finally, how many ASBRs are there?
1.
This router here
This one.
connects the
Yeah.
OSPF network to the internet and likely advertises a default route into the OSPF domain.
Right.
Let's go to question 4.
Wait, there's a question 4.
Which of the following commands will make
Oh.
R1 an OSPF
Okay, never mind.
ASBR? Here are the options.
Default originate.
B, C, and D.
There it is.
Pause the video to
Wait, yeah, it's B. It's
look
B.
at the options and select the best answer.
It wasn't shown in the discussion. But this first command wasn't shown in the discussion, but this is how you do a default route. So 0.0.0.0, your IP address, same as the subnet mask, and then you use the exit interface. Well, this is an exit interface, but this is like the IP address of the router's interface to the ISP. If I'm not mistaken. Is it the ISP? Is it the ISP? Has to be.
The
This is a
correct
weird
answer is
IP
B,
address.
which first configures a default
Yes.
route and then advertises it
Come
into
on.
OSPF using the default information originate command.
Yes,
Option
default
A
information
simply
originate.
configures 2 network commands which activates OSPF on the specified interfaces.
Mm.
Option C activates OSPF on all interfaces with an IP address, since all IP addresses match 0.0.0.0/0. Option D is not a real command. Let's go to question 5. Which command can be used to manually configure the OSPF router ID? Here are the commands. A, B, C, and D.
Wait,
Pause the video to examine.
pause. Thank you, Jeremy. Manually configure the It's A. I don't need to explain that.
Examine the commands and select the correct answer.
This one's just command memorization. It's
The
A.
correct answer is A. Router ID 1.1.1.1, entered in OSPF configuration mode.
Yeah.
The command to manually configure the EIGRP router ID is EIGRP router ID. But for OSPF, it's just router ID.
Come on.
Option C configures an IP address on a loopback interface. If the router ID isn't manually configured, this IP address might become the OSPF router ID, but it's different than manually configuring the router ID.
Right.
That's all for the quiz. Now let's do a
What?
bonus question from Boson XSIM.
We're doing a
for
bonus
CCNA.
question. I love bonus questions.
Okay, here's today's Boson XSIM practice question.
What the frick?
You administer the OSPF network above.
Okay.
You issue the default information originate command on router A. Which of the following statements are true? Select two choices. A. OSPF will advertise router A's gateway of last resort. B. Router A will become the OSPF ABR. C.
ASBR.
OSPF will summarize all of router A's directly connected routes. D. Router A will become the OSPF ASBR. And E. OSPF will redistribute all of router A's directly connected routes. Okay, so pause the video here to think about your answer.
Well, it's definitely D. E, maybe it's OSPF will redistribute. Yes, it's D and E. It's D and E because it redistributes routes, right? It's just D and E. It does just look like a question.
Okay, so let's check the answer.
It's
so there
D&E.
are two choices. We use the default information originate command, which we just covered in this video, as well as the previous video on RIP and EIGRP. So what this command does is it advertises the router's default route into that routing protocol, OSPF in this case. So that means A is one of the correct options. OSPF will advertise router A's gateway of last resort. That is the default route.
Wait, what was the explanation? So it's not E. It's not E. It's D and A. Advertises the default route. Okay.
Advertises the router's default route into that routing protocol, OSPF in this case. So that means A is one of the correct options. OSPF will advertise router A's gateway of last resort. That is the default route.
Oh, right. It's the last resort.
Okay, next. It's either B or D is the second correct choice. Will router A become the OSPF ABR, or will router A become the OSPF ASBR?
Well, if it's connected to the ISP, it's supposed to be the ASBR. Or, well, I just understand if I use default information originate since it floods. It floods LSAs. Then it should be the designated ASBR because that's what all the routers know, right? Like all roads lead to me. Call me faker router. Legends never die.
So an ABR is an area border router. It is an OSPF router that has interfaces in two separate OSPF areas. Usually area 0, the backbone area, and one other area. Now an ASBR, Autonomous System Boundary Router, is an OSPF router that is connected to an external network outside of the OSPF domain. And it shares information into the OSPF domain about those external networks. So that makes D the correct answer because this default
Okay,
route
I'm half
is
correct.
probably a route to the internet, for example.
No, I almost
and router A
aced the
advertises that default route into the
quizzes.
OSPF domain. So let's check the answer.
I
Click on Show
almost
Answer
did
down here.
it.
And we are correct.
Blood.
So this is Boson's explanation of this question. Not only why A and D are the correct options, but also why B, C, and E are incorrect.
Wait, there's an explanation. Let's summarize all of... Oh, okay, it's a different command. Okay. So there's no redistribution and... Okay, yeah, directly connected routes. So what this answer says is that it distributes router A's everything. It just advertises everything that it's connected to, which is not what it's supposed to do. So when you say, let's go back here. You say R1. R1 does default. Did he show the command here? Oh, it's easier to talk about. Where's default originate? Default information originate. Show me. There it is. Okay. So when you use this command, it only floods LSAs to OSPF activated routers. So I think in this configuration, we've already done that with all of these. It doesn't talk about the ones that don't have it activated. So we used passive. Since we used passive interface on G20, which is this one, using this command doesn't reveal this. Like, this is R1's personal space, in a sense. You're not supposed to know about that. So I definitely got the question wrong. I just misread it. My English is bad. Sorry, I don't speak English. Oh, hello, Nickens. Yeah, I'm a redistribution. I'm a pawn that'll reach the end of despair. Type B. Howdy. Well, that's part 1, y'all. Should I do part 2 or should I go to sleep? Or should I study part 2 while going to sleep? Let's do that. How about that? That sounds like deal. Deal, no deal. Mass-produced Zeppi. Can you imagine? We get a gremlin army. Yeah, I wanna be mass-produced. Wait, it sounds wrong. You know what? Never mind. Let's go to part 2. That's a good one. Good one.
Welcome to Jeremy's IT Lab.
Let's
is a free...
skip your intro, sir.
We'll cover 3 main topics. First up, OSPF's metric, which, as you know, is called cost. It's not so difficult to understand, so you should know it well for the exam.
Is everyone okay?
The next topic will
I think we should take a short break because all I did was yap about the protocols. How's it going, everybody? Are we okay? Are we okay? More studying. Oh, don't worry, I'll fall asleep. Uphold my legacy. Epidine. Epidine always delivers. Nickens sent me a no, this weekend. More studying. You know, I've already taken notes for these. I just need to revisit them. Let's see what the 3 topics
how routers
are.
become OSPF neighbors. I've mentioned OSPF neighbors previously, but haven't actually shown you the actual process. We'll go in depth in this video.
Oh boy.
Finally, I'll introduce some more OSPF configurations. Make sure to stick around.
More OSPF configuration, so it's more commands. OSPF metric is basically cost. So every time all connections have like a cost set up, from what I understand. So the connection from R1 to R2, you'd say it costs like 10. But the connection from R1 to R3 costs 20. So now you're gonna look for a path to R4. If you have a topology, oh, how convenient. It's the same topology. So say that the cost of this connection is 10, R1 to R2 is 10, R1 to R3 is 20, and then the connection from R3 to R4, the same for R2 to R4, is 5. Let's just say both of these costs are equal. The only thing that's different is the connection from R1's end. So the lower the cost, the better, right? So when you set the metric, say this is 10, this is 20, and then they have to go through R4 to R4, which is plus 5. 20 plus 5, 25 versus 10 plus 5, 15. Obviously, going from R1 to R2 is the fastest route to R4. Just because it costs less. But you know what? That doesn't matter. You don't have to do it like that. If you just want if you want routers to prioritize the one specific router, you just set that router to a low cost. That way everyone eventually goes that way. And that should be it. Becoming OSPF neighbors. Maybe we can skip the cost and go straight to... Oh, there's a summary. Yeah, let's go through the summary. Oh yeah, here you go. Yeah, setting it in bandwidth. I don't know why it's set in kilobits. But yeah. That's one of the options for you to do that. This way, if you don't manually... I think this command is what you use if you don't want to manually modify the OSPF cost. So this one automatically does it for you, but it has to be the same reference bandwidth for all of the routers, if I'm not mistaken. Let's go at it. Let's see.
Let's summarize. There are 3 ways to modify the OSPF cost. First is to change the reference bandwidth. The command is autocost reference bandwidth, and then the reference bandwidth in megabits per second, entered in OSPF config mode. Next is to manually configure the OSPF cost of the interface with the command IPOSPF cost, entered in interface config mode. Finally, you can also change the interface bandwidth, although this isn't recommended. The command is bandwidth, followed by the bandwidth in kilobits per second, entered in interface config mode.
That's not ideal.
I already showed you the show IPOSPF interface command, but here's a quicker way to check the OSPF cost of each interface. Show IPOSPF interface brief gives a convenient overview of each OSPF enabled interface on the router.
Yeah.
Okay, let's move on to the next topic. This is another very important topic in OSPF, OSPF neighbors. Making sure that routers successfully become OSPF neighbors is the main task in configuring and troubleshooting OSPF.
Right.
Once routers become neighbors, they automatically do the work of sharing network information, calculating routes, etc. So you just have to make sure that OSPF is activated on the correct interfaces, and that the proper conditions are met to allow the routers to become neighbors. Of course, there are more advanced OSPF configurations you can do, but for basic OSPF operation, they aren't necessary. However, if routers can't become OSPF neighbors, OSPF can't operate at all, so this is very important. So how do routers become OSPF neighbors? When OSPF is activated on an interface, the router starts sending OSPF hello messages out of the interface at regular intervals, determined by the hello timer. These are used to introduce the router to potential OSPF neighbors. By exchanging hello messages, they check that they are compatible to become OSPF neighbors, and then negotiate their neighbor relationship. By the way, the default hello timer is 10 seconds on an Ethernet connection. Remember this number. OSPF hello messages are
10 seconds default timer.
IP address 224.0.0.5, which is the multicast address for all OSPF routers. Do you remember RIP's multicast address?
No,
it's
I didn't study RIP.
224.0.0.9. How about EIGRP?
Nope, I didn't study that either.
224.0.0.10. Also, OSPF messages are encapsulated in an IP header, and the protocol field of the IP header has a value of 89 to indicate OSPF.
Oh,
If you need a review of the IP header, go back and watch day 10 of the course again. Okay, for OSPF routers to become neighbors, they have to go through various neighbor states. I'll give a basic overview of each of the neighbor states. I recommend taking notes for this section. Although it will be just a basic overview, I'm going to give you a lot of information over the next few slides.
I should check my notes.
So let's assume OSPF is already activated on R2's G00 interface. Then, OSPF is activated on R1's G00 interface. It sends an OSPF hello message to 224.0.0.5. There are more fields in the hello message, but two important ones are R1's router ID and the neighbor's router ID. However, R1 doesn't know about R2 yet, so the neighbor router ID field is O.O.O.O. R1 doesn't know about any OSPF neighbors yet, so the current neighbor state is down. This is the first OSPF neighbor state, down. When R2 receives the hello packet, it will add an entry for R1 to its OSPF neighbor table. In R2's neighbor table, the relationship with R1 is now in the init state. Note that R1 still doesn't know about R2, so it will have no entries in its OSPF neighbor table.
Right.
Basically,
it has to reply,
the init
right?
state means that a hello packet was received, but R2's own router ID is not in the hello packet. R2's router ID is 2.2.2.2, but the neighbor router ID in R1's hello packet is O.O.O.O. So that's the init state. The next state is the two-way state. R2 will send a hello packet containing the RID of both routers. R1 will insert R2 into its OSPF neighbor table in the two-way state.
The reply is important.
Then, R1 will send another hello message, this time containing R2's RID. Now both routers are in the two-way state. The two-way state means the router has received a hello packet with its own RID in it. If both routers reach the two-way state, it means that all of the conditions have been met for them to become OSPF neighbors. They are now ready to share LSAs to build a common LSDB.
Right.
On the other hand, if they fail to reach this two-way state, you know that
no
you
OSPF.
have to troubleshoot and find what's stopping them from reaching it. In some network types, a DR, designated router, and BDR, backup designated router, will be elected at this point.
Yes.
I will talk about OSPF network types and DR, BDR elections in day 28, so don't worry about them for now.
Bruh. Well, I already know how how it works. So, DR and BDR, they're basically it's basically just like nomination of the big boy router. Same as how whatchamacallit? Same as how ASBRs are designated. But this time it's usually determined by router ID, if I'm not mistaken. Let me check my notes. Let's see here. Yeah, highest router ID or highest OSPF, like the process ID. That's how they do it. Whatchamacallit? Oh, and in terms of sharing LSAs, this is the reason why you can't take down, you can't clear an IP. What you call it? You can't reset the process like we did on the last video. He also said that it's not recommended, and it's definitely not something that you're supposed to do in a real setting, because once one router shuts down or clears the process, everyone will follow suit. It's gonna get reset. Everyone's gonna rebuild the entire table again, and that'll cause, depending on how large your infrastructure is, a lot of downtime, basically. Yo, Nickens with a streak. Snow this weekend. Yes. Oh, yeah. It's gonna snow this weekend. It's my first time seeing snow. Oh my gosh. It's very likely that it's going to snow. I don't trust Vancouver weather. Sometimes they say it's sunny, but it's raining like shit. So it's like peak Filipino things. Never trust the weathermen. Anyway, moving on.
I just wanted to introduce the terms DR and BDR. At this point, the
It's
routers
almost
are
11. I don't
already
think we're going to
OSPF
finish this
neighbors.
video.
Over the next few neighbor states, they will share LSAs and form a full OSPF adjacency. Let's go to the next neighbor state.
I'm Frank.
After the two-way state, the two routers will now prepare to exchange information about their LSDB.
Mm-hmm.
Before that, they have to choose which one will start the exchange.
That's when the
So they will
nomination
decide which one will be
starts.
the master router and which will be the slave router. Note that these are different than the DR and BDR I mentioned in the last slide. This master-slave
so it's not the
relationship
nomination.
is only needed for this initial exchange of LSDB information.
It's so fucked up now.
They decide
These
which will be
days,
the
just
master
say that.
and which will be the slave in the X-start state. The router with the higher RID will become the master and initiate the exchange.
Right.
The router with the lower RID will become the slave.
The idea has no
So in
impact
this
here?
case, R2 will be the
Question
master
mark?
and R1 will be the slave. To decide the master and slave, they
Right, 'cause
exchange
222.
DBD, database description
What, Dead by
packets.
Daylight?
DBD packets are also
What?
important in the next state, so I will talk more about them in the next slide. Basically, the X-start state is just to prepare for the next state. R1 sends a DBD packet claiming to be the master. However, R2 corrects R1. R2 has the higher router ID and says that it will be the master. In the next state, the exchange state, the routers exchange DBDs which contain a list of the LSAs in their LSDB. These DBDs do not include detailed information about the LSAs, just basic information telling their neighbor what LSAs they have. Basically, the routers are telling each other, I have these LSAs, but they aren't actually sending the LSAs yet. The routers compare the information in the DBD they receive to the information in their own LSDB to determine which LSAs they must receive from their neighbor. After exchanging DBDs, they move to the next state. The next state is the loading state. In the loading state, routers send link state request, LSR messages, to request that their neighbors send them any LSAs they don't have. In the exchange state, they exchange DBD packets, so they know which LSAs their neighbors are holding. So these LSRs are used to request any missing LSAs, to make sure each router has the same LSAs. I'll just show one side of the exchange, but R2 will also send R1 LSRs for any missing LSAs.
How do you know what LSAs are missing?
Then the LSAs themselves are sent in link state update, LSU messages. R2 sends R1 the requested LSAs in an LSU like this.
Wait, Sword? Those are LSRs just basically in the exchange phase, whatever LSAs that they haven't seen before, they're just gonna request it straight up? Is that what's happening? I guess so. Because the way it works is that OSPF interconnects all of the routers that are configured for OSPF, so it should work like that. Just completing the information that they need and want, right?
R1 will also do the same for R2. Finally, the routers send LSAC messages.
LSAC.
Another kind of OSPF message, to acknowledge that they received the LSAs.
Why am I like this?
Now the loading state is complete, and the routers have the same LSDB.
Yay!
We've reached the final OSPF state.
Yay!
In the full state, the routers have a full OSPF adjacency and identical LSDBs. But that doesn't mean things are complete. They
There are
continue to
more.
send and listen for hello packets, once every 10 seconds by default, to maintain the
Yeah.
adjacency. To
Because when a
maintain
new
the
one
adjacency,
arrives.
another timer called the dead timer is used. Every time a hello packet is received, the dead timer, which is 40 seconds by default, is reset.
It is.
However, if the dead timer counts down to 0 and no hello message is received,
Assume
the
it's
neighbor
dead.
is removed.
Yep.
If the neighbors remain up, the routers will continue to share LSAs as the network changes to make sure each router has a complete and accurate map of the network.
Right.
This is the main
Always
advantage of
consistent
dynamic
updates.
routing protocols. The routers automatically react to changes in the network and add, remove, or change routes as necessary. Let's summarize that process.
It's huge.
First of all, the connection between R1 and R2 comes up, or OSPF is activated on the interface, which starts the process. The first state is the down state. R1 and R2 don't know each other yet, but they will send hello packets out of their interfaces. Let's assume that R1 sends the first hello packet. The init state is when R2 receives that first hello packet from R1, but R2's own router ID isn't in the packet yet. In the two-way state, the routers exchange more hello packets, but R1's router ID is included in R2's hellos, and R2's router ID is included in R1's hellos.
Yeah.
In some kinds of OSPF connections, an election for the designated router and backup designated router takes place. I will talk about this more in day 28. Next is the X-start state.
Right now, R2 is
The routers exchange
designated router.
DVD packets to determine which will be the master and which will be the slave.
If they do get elected, is
The master is the router
ID.
that starts the DVD exchange in the next state, the exchange state. They exchange DVD packets to tell each other about the contents of their
And by
LSD.
daylight packets.
The next state is the loading state. They use LSRs, link state requests, to request LSAs from each other. The LSAs are sent in LSU, link state update packets. Finally, LSAC packets are sent to acknowledge that they received the LSAs they requested. Finally, the routers reach the full state, and they have a full OSPF adjacency. Do you remember this slide from day 26? The three main steps in the process of sharing LSAs and determining the best routes to each destination are 1. Become neighbors, 2. Exchange LSAs, and 3. Calculate the best routes.
I don't think was that in
Looking at
the
this
last
process
video?
again, these
That must
first
be
three states involve becoming neighbors. These 3 involve exchanging LSAs to synchronize the LSDB, and then the routers use the metric I taught you to calculate the best route to each destination. That's a basic overview of how OSPF works.
Wait, that's the entirety of OSPF.
Also, here's a quick summary chart of the 5 different OSPF message types.
Oh my god. Let's read it. Right. The hello, just to find the neighboring routers if they exist. If they do, the new router sends it back as well. They do a hello in response, and then they show their LSDBs, and then they're gonna request LSAs, the ones that they don't know, comparing it from the other router's LSDB, and then they send it, and then they acknowledge it.
Types.
Yay!
Notice that they are numbered from 1 to 5.
Routers!
1
Oh
being
my
hello,
god.
2 being DBD, etc. I already described the basic purpose of each of these messages, so you can pause the video here or take a screenshot if you want to use this chart to review.
Oh no, I'm good. Thank you.
After that overview, let's take another.
Here, I'll pause it for everyone or anyone that wants it. You'll have my face on it too. How about that? How many acronyms can we fit in a sentence? I don't know. I hope I just remember it tomorrow when I wake up. I'll be greeting my blockmates. Hi Zeppi. Hey LSDB. Huh? What do you mean? Who the frick is LSDB? I've done it once, just because I forgot their name. I just threw a random concept. It's so over. It's all ogre now. Right. That should be enough time.
After that overview, let's take another look at a few OSPF show commands. You should understand the output a little better now. Here is show IP OSPF neighbor. I entered
Okay.
it on R1. Note the full state with both neighbors R2 and R3. Also, both R2 and
Ended
R3
by
are
database
DRs.
description.
Again, I will explain DRs in the next video. Also notice the dead time. This counts down from 40, but resets as soon as R1 receives a hello packet from the neighbor. So, assuming a hello packet is received every 10 seconds, it should count down to 30, reset to 40, count down to 30, reset to 40, etc.
Yep.
Now let's take another look at
40
show
seconds is the
IP
default for
OSPF
dead time.
interface, looking at R1's G00 interface. You can see the default hello and dead timers of 10 and 40 here. Hello due in 7 seconds means that R1 will send a hello message out of this interface in 7 seconds, as it
This
does
is
once
pretty
every 10
self-explanatory.
seconds. Neighbor count is 1. Adjacent neighbor count is 1.
Wait. Okay, I don't know what that is.
R1 has only one neighbor connected to its G00 interface. That's
Okay.
R2. In the next video, I'll tell you the difference between a neighbor and an adjacent neighbor.
What?
Finally,
tell me now.
Adjacent neighbor 2.2.2.2, designated router.
You have to tell me now.
As we saw above in show IP OSPF neighbor,
It doesn't make sense.
R2 is a designated router. Again, I'll talk about that in day 28, but
Why? Neighbor count is 1. Of course, yes, they send a hello packet. Adjacent neighbor count. They're next to each other. Shouldn't it be? Shouldn't it be? Should it make sense? Should that make sense? I'm just gonna throw a blind guess for y'all here. So I'm correct with the adjacent neighbor concept. So adjacent is the ones that are directly connected to the interface of the router. And maybe neighbor count includes the ones that aren't connected, but they have the LSDB of them, or the LSA. So like router 4. If everything is configured, yeah, if everything is configured, wait a minute. No, I shouldn't be making these guesses because it's only talking about one interface.
but
No.
feel free to do a Google search to learn about it.
Everything I just said is cap.
Okay, that's
Don't-
all
don't-
for OSPF neighbors for today. We will cover a
listen
few
to
more
me.
details in day 28. Let's move on to look at a little bit more OSPF configuration.
We're almost done.
I already showed you a few new OSPF configurations when we talked about OSPF metric, specifically the auto cost reference bandwidth command
Okay.
and IP OSPF cost command. So let's just look at a couple additional configurations. First off, do you remember the purpose of the network command? It's the same for RIP, EIGRP, and OSPF. It simply tells the router which interfaces to activate the routing protocol on. Well, you can actually enable OSPF directly on an interface without using the network command. For example,
How?
let's assume that R1 has no OSPF configurations on it yet. Here's how to enable OSPF on the interfaces.
Oh,
You can activate OSPF directly on an interface with this command. IP OSPF,
I don't need to do router
followed by the
OSPF.
process ID, then area, and the area ID. Note that this is done from interface configuration mode. Now OSPF is enabled
But this
on
doesn't
those
set a
interfaces,
router ID.
and I haven't even entered OSPF configuration mode. Next, another method to configure passive interfaces. Can you see the difference? You can configure all of the router's interfaces to be OSPF passive interfaces by default with the command passive interface default. Then you can use the command no passive interface to remove that, only from specific interfaces. This is simply another way to configure
I
passive
submitted my test
interfaces.
paper that I'm
Depending on the number of
sorry.
passive interfaces you need to configure,
Don't ever listen
this
to me
method
ever
might be
again.
faster, or perhaps the normal method is faster.
You'll get a 0.
Either way, the effect is the same. If you configure OSPF directly on the interfaces, you'll
Sorry.
see slightly different output from show IP protocols. The routing for network section is empty, and instead, the interfaces you activated OSPF on are displayed here.
In
Routing
area
on
0.
interfaces configured explicitly. The rest of the output is the same, however. Before
Huh.
moving on to today's quiz, let's review
Same
what
command,
we
different
covered.
format.
First up, I showed
Sorry,
you
different
OSPF's
command,
metric called cost.
same info, different
By
format.
default, it is automatically calculated by dividing the reference bandwidth by the actual bandwidth of the interface.
Mm,
However, if the result is a value less than 1, it is converted to 1.
right, decimals are rounded up.
Default reference bandwidth is 100, so anything equal to or faster than 100 megabits per second has an equal cost of 1. You can modify the reference bandwidth with the auto cost reference bandwidth command.
Mm,
You can also manually configure the cost of an interface
right.
with the IP OSPF cost.
I feel like auto cost is the best option for this
more
one.
option to modify an interface's cost is to change the bandwidth with the bandwidth command.
But we don't
although
use
this
that.
isn't the recommended method.
Yeah.
Finally, a route's metric is the total cost of the outgoing interfaces in the route.
Mm-hmm.
Next, we study the process routers use to become OSPF neighbors. Here's the summary
Right.
diagram. This is probably the most difficult section of this lecture.
Yeah, if I
recommend
have to
watching it a
remember.
few times,
I
and
have to
perhaps doing
remember
a
the
Google
names.
search for OSPF neighbor states.
Down
to
in
learn
it,
more about the
two-way,
process.
DRBDR election, Xstart exchange.
Finally, I introduced a couple more OSPF
I
configurations.
already
Instead
forgot.
of using the network command,
Go back.
you can activate OSPF directly on an
Exchange loading full. Okay, there you go. Down, initialize, two-way, DR/BTR. That one's optional. Xstart, exchange loading in full state. Yo, hello, Lucky. How's it
Finally,
going?
I introduced a couple more
I'm nerding
OSPF
out. Yeah, I have
Instead
to
of using the network
lock
command,
it in.
you can activate OSPF directly on an interface with this command.
Mm,
As an alternative method of configuring passive interfaces,
is that
you can
better
configure all
than
interfaces as passive with the passive interface
is doing
default
this more ideal than router
and then only make
OSPF though?
specific interfaces active
Maybe not.
after. Make sure to watch until the end of today's quiz for a bonus question from Boson
It's
XSIM
quiz
for CCNA, a set
time.
of practice exams for the CCNA, and the best tool to get ready for the real CCNA exam. Okay, let's go on to quiz question 1.
Time for the quiz, gang.
Put the OSPF neighbor states in
Oh,
the
we're
correct order.
fucked.
Here are the neighbor states. Order them from 1 to 7. Pause the video now to think about.
Oh, never mind. I remember. Down. Init. Two-way. Fuck. Down, init, two-way. Xstart. Exchange. Loading full.
Your answer.
Right.
Here's the answer. Down,
Okay. Init.
init,
Two-way.
two-way,
Okay. Exchange. No. Xstart. Xstart first.
xstart,
Xstart. And it's exchange.
exchange,
And it's loading and then it's full. Lock it in.
and full.
Lock it
A
in,
full
gang.
explanation
Lock
of
it in.
each
Lock it
state
in.
would take too long. So go back in the video if you don't remember the order and purpose of each state. Let's go to question 2. Which statement about OSPF's default cost is correct? A. All interfaces have the same cost.
No.
B. Ethernet and fast Ethernet interfaces have the same cost. C. Fast Ethernet, gigabit Ethernet,
Ooh.
and 10 gig Ethernet
We didn't.
interfaces
I didn't show
have the
this.
same
I didn't
cost.
show this part of the video.
And D. Ethernet, fast Ethernet, gigabit Ethernet, and 10 gig Ethernet interfaces have the same cost.
B.
Pause the video to think about the answer.
Right? Or maybe it's
The
all.
answer is C. Fast Ethernet, gigabit Ethernet, and
No.
10 gig Ethernet interfaces have the same cost. by
Alright, no,
default.
because Ethernet I think is 10 MBS. Is it 10 or 100? No, it has to be 10. It has
The
to be
cost
10.
is calculated by dividing the reference bandwidth by the interface bandwidth. The default
Ethernet's
reference bandwidth
at
is
10.
100 megabits per second.
Bandwidth
So a
is
fast
10.
Ethernet interface has a cost of 1. However, anything faster than that will have a cost of 1 as well, because all values less than 1 are converted to 1. Let's go to question 3. In which OSPF neighbor state are the master and slave roles decided? A. Xstart. B. Two-way. C. Exchange. Or D. Loading.
It's either two-way or
Pause the video
Xstart.
to think about the answer.
It's gotta be Xstart. Because hello and then init just the hello packet is received by the other router. That's the init state. And then the two-way is just the response. So Xstart is the determination of how, yeah, Xstart is basically saying, oh, I'm the master router. No, I'm the master router. So it's gotta be Xstart.
The answer is A. Xstart.
Okay.
A master and slave need to be decided in the
Let's
Xstart
go.
state. The master is the router that will start the database description (DBD) exchange in the following state, the exchange state, which is
Dead by
option
Daylight.
C. In option B, two-way, a designated router and backup designated router are selected in some cases, but not a master and slave. In D, the loading state, LSRs, LSUs, and LSACs are exchanged, but a master and slave are not decided. Let's go to question 4. Which of these commands can be used to make a fast Ethernet interface have an OSPF cost of 100?
We didn't show this.
A. Auto cost reference bandwidth 100. B. 1000. C. 10,000. Or D. 100,000.
Since this is in megabits, I have an OSPF cost of 1000. I think you have to do 10,000. His default is 100. So, if you check the formula again, where is it? Reference bandwidth, right? Reference bandwidth divided by interface bandwidth. So fast Ethernet, I believe, is 100. The interface bandwidth of fast Ethernet is 100.
C. 10.
So if you do 10,000, if you use the reference bandwidth of 10,000, it'll the answer should be 100.
1,000. Or D. 100,000. Pause the video to think about your answer.
Only fast Ethernet's actually 100, so I don't know about that, but I'm pretty sure it's 100. So the answer is
The
C.
answer is C. Auto cost reference bandwidth 10,000. Once again, the cost is calculated by dividing the reference bandwidth by the interface
There you
bandwidth.
go.
A fast Ethernet interface has a bandwidth of 100 megabits per second.
I got it.
10,000 divided by 100 equals 100. So you should set the reference bandwidth to 10,000. Let's go to question 5. What are the default OSPF hello and dead timers on an Ethernet connection? All
I know
times
this
are in
one.
seconds. A. Hello 2 seconds, dead 20 seconds. B. Hello 10 seconds, dead 40 seconds. C. Hello 30 seconds, dead 120 seconds. Or D. Hello 60 seconds, dead 180 seconds. Pause the video to think about your answer.
I know it. It's B. I don't need to explain it. This is just default seconds. It's B.
The answer is B. The default hello timer on an Ethernet connection is 10 seconds, and the default dead timer is 40 seconds. Now, I haven't mentioned this in this video, but
Bonus
for some
question.
other kinds of connections, the default OSPF timers are actually 30 and 120, as in option C.
Oh,
However, for Ethernet connections, the defaults are 10 and 40.
maybe for serial ports?
I'll talk about some other kinds of connections in day 28.
Maybe in serial
Okay,
ports.
that's all for the quiz. Let's take a look at a bonus question from Boson XSIM for CCNA.
Boson XSIM is actually
Okay,
really
here's
good.
today's Boson
It's just that you
XSIM
have to
practice
pay.
question. You administer the OSPF network shown in the diagram above. The autocost reference bandwidth 1000 command has been issued on every router in the network. What is the cost of the route from router A to router C? Okay, A, 11, B, 3, C, 12, D, 2, E20. Pause the video to think about your answer.
We gotta calculate the whole thing. I don't know if you guys can see it, but yeah. Router A to router C is, so this is A to C. So A to C. And the reference bandwidth is 1,000. So maybe it's 1,000 divided by 1,000 is 1. 1,000 divided by 100 is 10. So this should be the fastest route. A to B to E to C, which is 1, 2, 3, 4. Because they're all 1 Gbps. So 1, 2, 3. Yeah, 1, 2, 3. It should be B. Hey.
Okay, let's check. So you set the reference bandwidth to 1000 megabits per second on each router.
Yeah.
So that would mean that these gigabit Ethernet connections, 1 gigabit per second, have a cost of 1 because 1000 divided by 1000 equals 1.
Yeah.
On the other hand, these 100 megabit per second fast Ethernet interfaces have a cost of 10 because, of course, 1000 divided by 100 is 10. So ideally, we will avoid any fast Ethernet interfaces because they cost 10 times as much as a gigabit Ethernet interface.
Right.
So the shortest route, without passing through any fast Ethernet interfaces, is from router A to router B. That is a cost of 1. Router B to router E, plus 1, so 2.
And E to C.
Router E to router C, plus 1, so 3.
Yes.
So the total cost from router A to B to E to C is 3.
Yeah.
Let's check the answer. Okay, that is correct.
We got
Here
it.
is
We got
Boson's
it.
explanation, quite detailed. And they, of course, show you the diagram with the same path that I chose. Router A to B to E to C.
I should probably get Boson XSIM by summer. Well, everybody, that was a non-stop studying sesh. It's almost 11:30. I have to wake up in like 7 hours. So maybe we should end it here. Well, I hope everyone had a bit of fun studying crazy stuff with me. Cause, well, it was fun. Well, it's not really fun, but it was fun learning alongside y'all. Even though this isn't exactly most of the people's expertise. We learned about neighbors and DBD. Well, we actually listened to a few things. But yeah. If you know nothing about what's going on, I don't think anything will make any sense even if you take notes of it. You'll understand how we're just studying a router protocol. So everything that we learned here so far is just one of two. I think it's just two. One of the two commonly used protocols. And all it does is route. Wow, who would have guessed? Because this is all about routers. This is router stuff. It's not about a connection from a router to a PC or a router to a switch or a router to the ISP. We're just talking about how routers interconnect to each other. Right? That's the scope of the topic. We don't care about IP addresses as much. The only purpose of the IP addresses in this topic is determining the entire network connection. Not internet, but the IP addresses that are already assigned. So it's more of a real scenario. What a thing. But yeah. Thanks. Maybe I can do more productivity streams. Maybe tomorrow's the day that I can do. Wait. Let me check my planner. If I could stream tomorrow, what could I do? Checkpoint quiz. Never mind. I'm not streaming tomorrow because there's a lot. Wait. No, I could stream tomorrow. But that's just more studying. Oh. Does anyone want to learn how certificate authorities work tomorrow? We're gonna talk about website security. Maybe not. Today I was just really hoping I could do like a video editing stream. No, maybe not. Maybe I'm not gonna stream tomorrow or Thursday. I guess I'll see you guys. Unironically, would want to. I'll see you tomorrow. That's all I needed to hear. Yeah, it should be a good. It should be a good opportunity to like test out studying streams. I never thought people would be so engaged over boring topics. Because even I get bored out. You know, if I was in the classroom listening to all that we went through, I would have been asleep. But I'd be taking notes. But I'd still be asleep. Yeah, I'll be back tomorrow. Okay, tomorrow will be about certificate authorities and cryptography. Cryptography is let's see what we have here. Oh wait, no, I gave up on taking notes on this one. My instructor was just straight yapping for 3 hours straight. I don't know how he does it. But I have respect for him. It's the fact that he doesn't stop talking is what makes it hard to take notes, because if I ever zone out trying to write something down, it's gone. I wish I could yap for 3 hours straight. I did that as a shoutcaster. That's probably the only time you'll ever catch me yap for 3 hours straight. Hello, Kinako. Why are you streaming on a weekday? Because I studied. I'm just doing my usual thing. That's literally all I did. I just wanted to try out study streams. See how that goes. Let me just see if I have an overview of tomorrow's studies. If you use Linux, I have to study regex. That might be something familiar for some of y'all. Well, I'm not studying regex. I'm just studying the search. How to properly search with regex. But that might be something that I can't show. Because if I boot up a VM, I have files that have personal information on it. So yeah, maybe it's just cryptography for tomorrow. We're gonna talk about algorithms. Algorithms, crypto systems, hash algorithms, and all that stuff. So yeah. Just use a regex interpreter. I don't even know. God. I have to do everything on scratch. Like we're doing it in a Linux CLI or a Linux terminal. It's hell. I wonder if I'll use it in a real life situation though. Probably not. Dang. Yeah. That's all I have for today. I should get ready to sleep. I don't want to lose another hour. I still have to doom scroll. That's a part of my thing. Let me doom scroll tonight, y'all. I'll probably be binge watching LC Signs shorts. Hi, homie. It's Tony. I don't even know what other videos I've been holding on. Zen Zero stuff, maybe. But yeah. I know. Well, that should be the end for real this time. I don't really have anyone to raid. Like no one's online. No one that I know is live right now. I don't have the energy to look for someone. I'm too EP to care right now or think. Yes, thanks again. Really appreciate it. I still couldn't believe that people got invested in OSPF. Even though y'all don't have the full concept, maybe it was like something worth trying to listen to. Yeah. Wish me luck for tomorrow. Thank you. I'll definitely pass this. You'll find out tomorrow. You'll find out tomorrow. Thank you. Thanks everybody. All right. Enough stalling. I really don't have any other announcements. There's nothing big coming up for me, so